One of my personal favorite snacks is the cheese toastie. Not because they particularly taste good, I mean I'm personally not a big fan of cheese, but because they can actually be used to teach a very difficult concept in chemistry, and that is the concept of limiting reactants. Let's say on a particular day you wanted to go into your fridge and make yourself a cheese toastie. The recipe for a cheese toastie is pretty simple. 2 slices of bread, 1 slice of cheese, and you're there. You've got yourself a toastie. But what if you go into your fridge and you have a very weird set of ingredients? So our recipe tells us we need 2 bread and 1 cheese to make 1 cheese toastie. But let's say we only have 6 slices of bread and 5 slices of cheese. Now what will happen in this case is that one of our ingredients is going to run out before the other. In this case, it is the bread. If we use all 6 slices of bread, we are going to end up using 3 of those 5 slices of cheese. In other words, we'll have 2 left over, right? And in other words, if we use 6 slices of bread, we use them up entirely, we will end up with 3 toasties. So in other words, we ran out of bread, we made as many toasties as we could, and we ended up with some cheese left over at the end. This is a very typical chemistry problem. It may not seem like a big chemistry problem, but it is. Because in this case, we've run out of one ingredient. The ingredient we have run out of is said to be limiting. It is in limited supply. Why this is important is because it's the limiting ingredient that determines how much of our product we're going to produce. We can only make as many toasties as our limiting ingredient will allow. When we run out of our limiting ingredient, we're done making toasties. The other ingredient though, the cheese in this case, is said to be in excess. In other words, we have more than what we need. We're not going to run out of it, we'll have some left over at the end. And the way to work out which one is limiting or which one is excess is our ratio up the top over here. We use that ratio and apply it to the numbers we actually have and determine which one is limiting and which one is excess. This concept in chemistry is known as the topic of limiting reactants. We can illustrate this using a chemical example, which is shown here, HCl plus magnesium. Now, what's important here is the ratios, the mole ratios in the equation. 2 HCl's for every 1 magnesium. So what we're going to do is we're going to see a set of scenarios, and for each of them we're going to try and identify which one the limiting reactant is and use that to work out how much hydrogen gas we're producing. Okay, scenario number 1, we go to our chemical storage cupboard and we find ourselves 0.1 moles of HCl and 0.2 moles of magnesium. Now we need to know which one of these we're going to run out of first. The way I do this is I normally base myself on one of these 2 reactants. Doesn't matter which one, I'm going to use the magnesium. And I work out how much of the other reactant I need based on that first one. So I'm going to say I have 0.2 moles magnesium. Therefore, I need 0.2 divided by 1 times 2, which is equal to 0.4 moles of HCl, right? So if I were to completely use up the 0.2 moles of magnesium, I would need twice as much HCl. In this case, 0.4 moles of HCl. When you do the I need column, you basically apply your molar ratios. Now, how much HCl do you actually have? You've actually got 0.1 moles. So you could say, but I have 0.1 moles HCl. I need 0.4, but I have 0.1, which means HCl is limiting. So if what you need is more than what you have, your HCl in this case is limiting. So basically work out how much of one reagent you need based on another one, and then compare it to how much you've actually got. And in this case, we've found that our HCl is limiting. Why does this matter? Because now we're going to use our HCl amount to work out how much H2 is produced. So your moles of H2 now, we're going to work out using your HCl. You go 0.1 divided by 2 times by 1, which should give you 0.05. Key thing here, you work out which of the reagents is limiting, and then you use that to work out how much of your product you have produced. And in this case, we've worked out that it's the HCl that's limiting, and as a result, you've only been able to produce 0.05 moles of H2. Now, you may be asked to take this further. You may be asked to find how many grams of H2 or what volume of H2 you've produced, but the initial steps are the same. You work out the moles of each reactant, you work out which one's limiting, use molar ratios to find moles of product, and then if you need to, take it that extra step further and find mass, etc. Okay, scenario number 2, now you've got, this is in a separate question, you've got 0.4 moles of HCl and you've got 0.1 moles of magnesium. Same deal, pick one reactant, doesn't matter which you choose, and work out how much of the other substance you need on the basis of that. So I'm going to use the magnesium again. I'll say I have 0.1 moles of magnesium, therefore I need, same deal, 0.1 divided by 1 times by 2, which is equal to 0.2 moles HCl. But I have 0.4 moles HCl. So in this case, I need 0.2, but I've actually got 0.4 moles HCl. So what can I say here? I can say HCl is my excess. I've got way more HCl than what I need. HCl is not going to run out. I need 0.2, I've got 0.4. So in other words, if HCl is in excess, my magnesium is limiting. So in this case, I'm going to use my moles of magnesium to work out H2. And I do this by going 0.1 divided by 1 times by 1. The ratio is 1 to 1. You can apply the ratio anyway if you're in the habit of doing it, but basically you're going to get 0.1 moles of H2, right? Same as the number of moles of magnesium. Now, I should preface this by saying a balanced chemical equation is a must when doing these problems. If you don't have one, you don't actually have a way of working out, first of all, which one's limiting, and also second of all, how much of your product you've produced. Scenario number 3, we've got an added layer of difficulty now. We've got 4 moles of HCl and 2 grams of magnesium. Now remember, molar ratios in equations can only be applied to moles. Right? They're a ratio of quantity, not a ratio of mass. So if we've got mass or volume or anything like that, we've got to convert it to moles first and then get into our question. So the first thing we've got to do before we get into any limiting reactant stuff is to convert my grams of magnesium into moles of magnesium. And to do that, I use my number of moles formula. Number of moles equals mass over molar mass. Mass in this case is 2, and molar mass of magnesium is 24.305. This should give us roughly about 0.0822. Now write as many decimal places as you can during the problem, but I've run out of space, so I'm just going to leave it at that. So in this case, I can say that I have 0.0823 moles of magnesium, therefore I need 0.0823 times 2 divided by 1 times 2, which in this case is 0.165 moles HCl if I use the full number of magnesium to convert this. So I need 0.165 moles of magnesium, of HCl, sorry, but I have 4 moles of HCl. Therefore, I can say HCl is excess and magnesium is limiting. And so finally, if I was trying to find moles of H2, once again, what would I do? I'd go 0.0823 divided by 1 times by 1, which would give me 0.0823. Our final question has another layer of complication. In this case, we don't have moles of HCl either. We've got concentration and volume. We've got a volume of 2 liters and a concentration of 0.5 m, 0.5 moles per liter. And we need to use this to find number of moles. N equals concentration times volume, C times V. In this case, the concentration is 0.5 times the volume, which is 2, which should give me a number of moles of 1. Number of moles of magnesium, same deal, we do N equals 0.5 divided by the molar mass, which is 24.305, which in this case gives you 0.0206. So in this way, if you've been given volume or number of, or mass or something else, you need to, regardless of what it is, convert to number of moles and then work out which one your limiting reagent is. Go through the same process for working out the limiting reagent. In this case, you can probably even just spot the limiting reagent is magnesium. And so we're going to use the number of moles of magnesium to work out number of moles of H2, and in this case, number of moles of H2 is once again 0.0206, and the same as the number of moles of magnesium. So long story short, regardless of what you've got, what kind of problem you've got, the key thing you've got to do is work out moles of each of the reactants, in this case HCl and Mg, compare them to each other, use one of them as your base, and work out how much of the other one you need on that basis, and then work out which one is in short supply, which one is going to run out first, the limiting reagent. Use the limiting reagent, in this case, in this question it was magnesium, to work out amount of the product, which in this case was H2. Do as much of this practice as you can and ask as many questions as you need. Thanks for listening.